Good evening, everyone. Welcome to the JJMO's virtual second Saturday stars for January 2021. Happy New Year. Tonight, we have a very interesting program. We have 4 sections to the program. The first one will be presented by Roger Moore, the current night sky viewing highlights. Then he'll pass to Bill Cloutier, who will give us a presentation of the expected missions and milestones that will happen this year. And then we have a special presentation by Connor and Doug. And you'll find out who Connor and Doug is in a few minutes. And then finally, Mark Polanski will give us a presentation on SpaceX's Starship rocket. Okay. Roger, would you like to start with the night sky highlights?
I would like to. Thank you, John. So good evening, everyone. This is intended to be something if you just go outside and look with your own eyes. You don't need any equipment. Although if you have a pair of binoculars, it'd be nice to bring those along with you. So this is what's up for the next month or so, from January 9th to early February. It's not a big eventful month. The Earth was at perihelion on January 2nd, which just means that in its elliptical orbit around the sun, we are closest to the sun, or we were closest to the sun on January 2nd. The only major meteor shower this month was the Quadrantids, and they peaked on the 3rd. That's a very short-lived meteor shower, so it's passed by now. It's an interesting one, though. Most meteor showers are named for the constellation that they appear to be coming from. The Geminids are from Gemini, Leonids from Leo, but there is no constellation Quadrans. So how did it get the name? Well, there used to be a constellation by that name. But in 1922, when the International Astronomical Union came up with the official constellations, they left that one off. But the name of the meteor showers just kind of held on. There'll be a new moon on January 13th and a full moon on January 28th. And then there's a moon-Mars conjunction on the 21st, and I'll explain that in a few minutes. So the observatory has a meteor camera that records the night sky all night, every night. And this is a aerial view of the Northeast. The observatory is located where you see that right in the center. Each green line represents the direction and relative distance to a meteor. And this is the meteors that we caught on the night of the Quadrantids. This is actually early morning, January 3rd. So we saw 18 meteors from that shower just in that one night. Getting back to perihelion, we're in an elliptical orbit. So right now in the wintertime, we are about 3 million miles closer to the sun than we are in the summertime. And you might wonder, if we're closer, how come we're not warmer? And that's because Earth's seasons are caused by the tilt of Earth's axis, not the distance from the sun. So right now, the northern hemisphere is tilted away, we get less sunlight. So the image that I'll show you of the night sky come from a mobile app this time. We've done Stellarium in the past, but this is going to be from a mobile app, Sky Safari, which is probably one of my favorite apps. It's not a free one, but it's very full featured, and I can't show you all of the features, but it's a wonderful phone and tablet app available for both iOS and Android. And these two second versions actually have the ability to control a computerized telescope. So just one thing I will show you, this is a screenshot from that app. And if you tap on an object, like I tapped on Mars, and highlight it, and then tap on this little selection button in the bottom, it'll pull up another menu, and you tap on object info, and that will give you all kinds of information about the object. It'll give you its location, its rise and set times, and then a narrative about the object in question. And then there's even an audio tour if you care to listen to that. So it's just a great app. So if you go outside tonight and look south, if it's clear, this is the view you see. This is probably one of my favorite all-time views for all year long is this southern sky in the wintertime. There's just so many things to see. Right now, we still have Mars around us, although it's receding. It's getting further away and dimmer as we get further apart in orbit. It was closest to us back in October. But we have the familiar Orion constellation, the two heads of Gemini. There's the Sirius, the brightest star in the sky. And there's a couple of star clusters. There's the Hyades, which also includes Aldebaran, which is actually not part of the cluster. And then the Pleiades. And you might test your vision by looking up at the Pleiades and seeing how many stars you can count with just your own eyes. If you're lucky enough to have a real dark sky, you'll also see this, which is the band of the Milky Way. So the winter Milky Way, that's actually looking out away from the center of the galaxy towards the edge of the galaxy. You're looking through the disk of our galaxy out towards the far outside edge of it. So getting back to the night view, this is what you would see if you had a pair of binoculars and you pointed them at the Pleiades. It's just a wonderful star cluster. It's just a scattering a handful of diamonds on this dark sky. It's one of our closest star clusters, 440 light years away, roughly. And the Japanese call Pleiades Subaru. And it was the star cluster was the inspiration for the logo you see on Subaru automobiles. Also, if you pointed at the Orion constellation, there's Orion's belt, you should be able to see just with binoculars this gray mist that is the Orion Nebula. And that's one of our closest star nurseries. New stars are being formed right there. And so this is the constellations you will see looking to the south. Ursa Major, that's where Sirius is, why it's often called the dog star. Orion, Taurus, Gemini. Looking to the west, this is the view you'll have. And some of the familiar constellations. Andromeda is getting lower in the west. And once again, you'll see things that we saw to the south, and you'll see things that we will see to the north. So facing north again, this is all about 9 o'clock tonight. Facing north, the view doesn't usually change much. These stars are stars that you will see all year long, all season long, all night long, but their position will change. This is Cassiopeia, this is the Big Dipper, and all these stars appear to rotate around a central point, which is that star right there, Polaris. So Earth's axis of rotation points almost right at Polaris. And if you could go out and watch this view, this is what you would see all night, because those stars would appear to be rotating around, excuse me, around the center point. And so this is the North constellations. Ursa Minor, the Little Dipper, that point right there at the end of the handle, that's where Polaris is. This is Ursa Major and the Big Dipper, and there's Cassiopeia. And then facing east, this is what you'd see at night. And the constellations that are coming up. And here's Leo is just starting to come up in the evenings. If you're a morning person, you get up around 6 o'clock tomorrow morning. This is the view you have. And you will be able to see a waning crescent moon. And then these are the constellations. There's Hercules, Lyra, Cygnus. These are constellations we typically associate with the summertime. They are coming up in the morning now, so they are up during the day. That's why we don't see them. We'll see them in the summertime when we get around the other side of Earth's orbit. There is a Moon-Mars conjunction on the 21st, and that simply means that they appear close together in the sky. And in a month from now, looking south again about the same time of night, you'll know, if you recall, Orion started off over here. Now it's shifted to the west, and that'll happen with all the objects. They will shift to the west as the month progresses. And then the east morning view, you'll see most of the same constellations, but again, they have shifted to the west. They've gotten higher in the sky from what they were a month ago. Moon calendar for the month. So as I mentioned, there's a new moon on the 13th. So that's when your skies will be darkest. And there's a full moon on the 28th. If you enjoy viewing the moon and you have binoculars, it's around this time, first quarter and waxing crescents, that you'll have the best views of the moon. So we have these long, cold January nights, but there's just some wonderful things to see in the night sky. I really urge you to get outside and take a look. And, you know, look at it this way, the days are getting longer. So there's sunrise and sunset times for tonight, for today, and for a month from now. And you'll see that we actually gain a little over an hour of daylight in that time. So the days are getting longer. I thank you very much. And please let us know if you have any questions. And if you happen to be on our YouTube channel, we'd really appreciate it if you could subscribe to our channel too.
Thank you, Roger. Bill Cloutier is going to join us next. And as Roger said, if you're on YouTube, please click on the subscribe button. If you're joining us from Facebook and you want to ask a question, you can send that question in and it'll be read for the presenter.
Thank you, John. Thank you, Roger. I agree. The winter sky is certainly, the stars appear more vibrant. And if you can take the cold and the wind chill, it's some of the best observing of the season. So tonight I was going to go over some of the things that we are looking forward to this year. It's going to be a very busy year in space exploration and also in the commercialization of space. This is probably the first time in at least 10 or 11 years where we're going to see some fairly large additions to the International Space Station. Russia has plans to add at least 2 science power modules and maybe 1 docking module over the course of the year. Some of these modules have been in the works for quite a while, and looks like now we're going to get the opportunity to see them on station. China is planning on constructing a brand new space station. They've had other versions, older versions that have been deorbited. This is a new station, and they're planning to launch the core of that station sometime in the first quarter of this year. And then by the end of the year, they hope to have it completed to the point where they can have 3 of their astronauts living and working on the station. Russia, after 45 years, is looking to go back to the moon. They've got a mission called Luna 25 that is targeting an area near the South Pole of the moon. And it'll be carrying a payload, it's an unmanned version, and it'll be carrying a scientific payload that will be able to do soil sampling and possibly some coring. I don't think the design has been completely finalized, but we are looking forward to the Russians, among other countries, expanding their exploration. India is going to try again. They had a mission that was almost successful. Unfortunately, a software glitch during the landing phase shut the engine off too early. And as a result, it fell to the moon and crashed. So they're going to repeat this mission. They already have the orbiter in place for relaying information, but they're going to attempt another lander and rover, again, near the South Pole. United States and NASA have been making some headway in getting back to the moon. Their program is called Artemis. Artemis is named for the sister of Apollo. And they've been working on some of the various components of their space launch system, including the main rocket and the components, as you see on the screen, that will carry the astronauts to the moon in the next 4 to 6 years, depending upon funding and how the testing goes. They are planning on launching an unmanned version of the rocket later this year. It will go to the moon and beyond into deep space for a total of about 3 weeks before returning to Earth. On its way, it will deploy 13 small satellites, some of them as small as a CubeSat. And a couple of these satellites we've got on the screen, NEA Scout, Near Earth Asteroid Scout. It's going to be targeting a small asteroid in the vicinity of Earth and surveying that with various scientific instruments. Sentinel is a small satellite. It's using yeast as a proxy for living organisms, and it's going to measure the radiation that is received by this payload. So it will give us some more information on what we expect the astronauts to face when they go into deep space. And the third one is called the Lunar Flashlight. This is a small satellite. It's using a solar sail to not only adjust its orbit, but it's also using that sail to reflect sunlight into dark craters that are not lit. And it's going to be able to analyze the reflected sunlight off those dark craters to look for water deposits. Again, a very important resource if we plan on going back to the moon. Water ice that we can use for various applications, including drinking water or rocket fuel. So the fact that we can find water on the moon will be critical. NASA has also embarked in a new program to engage commercial companies to provide services. And we're going to see 2 of those companies deliver scientific payloads to the moon's surface this year. The one on the left will land somewhere around the Aristarchus Plateau, which, if you're looking at the full moon, is in the upper left quadrant. The one on the right will be landing more or less in the upper right quadrant, just above the Sea of Serenity. They're delivering different types of payloads, but this is a demonstration, and NASA hopes to expand this to other companies so that they can outsource some of this effort. Jupiter will get a new mission this year, and an old mission that yesterday was renewed. The Juno Spacecraft has been orbiting Jupiter for the past 3.5 years, studying the internals of the planet, looking deep into the atmosphere, the magnetic field, trying to determine what the core might be made out of, and studying the weather patterns. Yesterday, NASA and their subcommittees met and decided that the science is so valuable that they're going to extend its mission out to 2025, as long as the spacecraft is healthy. A new mission launching to Jupiter, or the area around Jupiter this year, is called Lucy. Lucy is going to fly through the asteroid belt, visiting one asteroid on its way, and then it's going to visit asteroids around Jupiter. Now, these are called Trojan asteroids. They share Jupiter's orbit, and they either trail the planet or they're in front of the planet as far as the orbit. So Lucy will investigate a number of those different asteroids. hopefully at the end of this year, we're going to see the newest space telescope in orbit. The James Webb Space Telescope has been long in development. You can see in the picture they're doing testing of various components. It all folds up very nice and neat to be placed inside the fairing of a large rocket. So once it gets into space, it's going to have to go through this process of unfolding and deploying all its instruments. And what you're looking at on the bottom, that mylar-looking substance, is a sun shield to keep the whole telescope as cold as possible. And that shiny material for, I guess, to give you an idea of how large that structure is, it's about the size of a tennis court. So you're going to fold all this up and then deploy it once you get into space. And this telescope is not like the Hubble. It's not going to be something we can service. This is going to be located about 1 million miles away from Earth. So it's a one-time deployment. And what we're going to be able to study with this telescope is the very earliest time in the universe when the first galaxies are forming. So we're going to look back over 13.5 billion years in time. Some other notable milestones or missions that are going on this year, we have DART. This is an asteroid deflection mission where we're going to purposely collide a spacecraft with a small moon that orbits an asteroid to measure how much deflection we get. And this might come in handy in the future if there's an asteroid that poses a particular hazard to Earth. So that's going to happen, at least launch this year. The lower left is the Osiris-Rex Spacecraft that has been orbiting the asteroid Bennu for quite some time. It actually leaves Bennu this year and makes its way back to Earth, arriving sometime in 2023. The lower right is the Parker Solar Probe, which has been studying the sun. And in this coming year, it's going to make 4 close passes. And what this probe does is it uses the gravitational energy of Venus to adjust its orbit and move closer and closer to the sun. So this year it's going to pass Venus twice, which will move it closer to the sun and make 4 close passes of the sun. We're also expecting a number of new launch vehicles to come into operation. United Launch Alliance is working on their Vulcan Centaur. That will eventually replace their Delta and Atlas rockets. Interesting twist here, the first stage is going to be using engines from a competitor, Blue Origin, who is also bringing a new rocket online in this year. So Blue Origin is going to be bringing their New Glenn rocket on. And as I said, these first 2 rockets are using the same engines for the first stage. We're going to get a more in-depth discussion on Starship in a little while. But Starship, which is SpaceX's deep space moon Mars rocket, has been going into development and some sophisticated testing right now. And we are expecting, we're hoping, for maybe an orbital launch sometime later this year. And the last one we touched upon a little bit, this is NASA's Space Launch System. This is the rocket that will carry the next astronauts to the moon and maybe beyond. And right now, that rocket is in various stages of assembly and testing. Now, if you tuned into the observatory talks earlier, and actually later last year, we had some talks on Mars. Last year was the summer of Mars. In July of 2020, there were 3 launches by 3 different countries, all going to the red planet. And that was because the red planet, Mars, and Earth were lined up so that sending a spacecraft to Mars at that time was not only the quickest way to do it, but also it was most fuel efficient way of getting to Mars. So the United Arab Emirates has a spacecraft called Hope, and it is scheduled to go into orbit around Mars in February, and it is planning on studying the upper atmospheres of Mars and how they interact with the lower atmospheres. China has a very ambitious Mars program. If you've been following China, it just completed a very impressive lunar program where they sent a spacecraft to the moon, dropped off a lander, collected samples, sent those samples back up into orbit, rendezvoused with the orbiter, and then that orbiter made its way back to Earth, delivering about 4 pounds of lunar material to the scientists in China. So this year, they're going to Mars. They have a spacecraft. Again, it's going to enter orbit in February. Part of that spacecraft is a lander and a rover. For the first few months, the main spacecraft will be surveying landing areas, looking for the most science-rich area to land. And once that's identified, they will deploy the lander. And if the lander is successful, the lander will deploy a rover. Again, with a suite of scientific instruments, everything from ground penetrating radar to chemical analysis. The third mission, and we're going to hear about this again in a little bit, is NASA's mission to Mars. Again, it's targeted to land on February 18th with a rover that looks much like the rover that's already working on Mars, but it's got a totally different suite of instruments. This one is a robotic astrobiologist. It's going to be looking for signs of ancient life in an ancient river delta that you can see that's false color on the right there. It looks like a river delta that you might find at the end of a large river, even in the United States, like the Mississippi. So they believe that the area they're going to land on was once a large lake, a lake with as much water as Lake Tahoe in Nevada and California. And the rover is going to be hunting for signs of life in this clay that they've identified from orbit. And when it finds something interesting, it's going to be able to collect the material, seal it into a canister, and then leave it at various points around the Martian surface for later retrieval. And right now, NASA and the European Space Agency are in discussions about that mission on how to return those samples back to Earth. And it will require several spacecraft and really a choreographed process where they go down to the surface, collect the samples, then launch them off of Mars. Again, rendezvous with a spacecraft orbiting Mars that will carry it back to Earth. This mission also has some interesting demonstrations, including one that will extract the Martian atmosphere and process it to remove the oxygen. And this would be something that colonists could use in the future, a means of extracting oxygen from the carbon dioxide that is the primary constituent in the Martian atmosphere. The other really cool demonstration is underneath the belly of the rover right now is a helicopter, a small rotorcraft that will be removed during the mission. And this helicopter will be the first of any kind of craft to fly on Mars. And it's worthy of a talk all its own, because you can imagine the atmosphere of Mars is is less than 1% of what you're experiencing right now at sea level on Earth. It's like being at 100,000 feet on Earth. That's how thin the air is on Mars. So the helicopter has to be able to perform and get some lift in that type of situation. So it's going to be really fun to watch. It's got cameras on it. So we're going to be able to witness first flight, Kitty Hawk moment on Mars. The mission also includes some microphones. So we're going to get our first sounds from the planet Mars. Again, the air is not very thick, so sounds are not going to be that intense. But it's going to be interesting to get the sound from an alien world. Coming up next is a pre-recorded video that was made by one of our younger members of the observatory, Connor. And Connor interviewed an engineer at NASA's Jet Propulsion Laboratory. The engineer is Doug Klein. You can see him on the left. He's standing in the Mars yard at the Jet Propulsion Laboratory where they do a lot of the testing of their vehicles. And Doug is the lead robotic arm systems engineer. He worked on both the Curiosity rover and the current Perseverance rover that's on its way to Mars. In December of 16, about 4 years ago, a key component of the drill that they used to gather samples stopped working on the Curiosity rover. So Doug and his team were in charge of finding a workaround to get that drill working again, which they did, and also to find an alternative method of transferring the sample from the drill to the internal suite of instruments inside the rover where it could be analyzed. So he's had some interesting challenges and some interesting stories from Curiosity. Maybe he's hoping that Perseverance won't be that exciting, but we'll find out. And what we have up next is Connor's interview with Doug.
Good evening. I am Connor, and tonight we will be speaking with NASA engineer Doug Klein. Hello, Doug.
Hi, Connor. Thanks for having me.
Doug, can you tell us a little bit about your job at NASA?
Sure. I'm currently the lead robotic arm systems engineer for the Perseverance rover, which is scheduled to land on Mars in about 3 or 4 months in February. Prior to that, I was one of the rover planners for the Curiosity rover, which landed back in 2012. And as a rover planner, I was part of the team that actually drove the rover around Mars.
What qualifications do you need to be able to drive a rover?
For several months. And so we'll do kind of 6-month out planning on where the rover is going to go. And then we can regularly update our location within those orbital maps to make sure that we're still on course for where we're trying to get.
Is driving Perseverance any different from driving Curiosity? And if so, why?
It is different. One of the biggest changes for Perseverance is that the sampling system is totally new. And so we're still in the process of kind of learning how to operate that new sampling system, but it collects cores and then deposits them on the surface of Mars for a future mission to be able to pick up and bring back to Earth, which is extremely exciting. And so that's one of the biggest differences. There's other kind of changes to the software to introduce more autonomy to make the job of the rover planners and the people operating a little bit easier.
Do you think its auto-drive feature will make your job easier or harder? And what qualifications do you need to be able to drive? Would it help you overcome the new terrain Perseverance will encounter?
I really think it will. Autonomous navigation, is a way for the rover to take pictures and then decide what the safest path is to traverse. And it's something that we're looking forward to using a lot and that we've made a lot of improvements for on Perseverance to make it more efficient and more effective for us to be able to use in a wider variety of terrain. So I think it's going to be a really cool capability, and we're really looking forward to it.
Thank you, Doug, and thank you for watching this video. If you would like to learn more, please go to NASA's or JPL's website. And for more videos, please visit the McCarthy Observatory website or our YouTube channel.
Thanks, Connor. That was great.
Good night.
Thank you, Connor and Doug. Next up is Mark Polanski with the Starship presentation. But you can see our future is bright when we have young volunteers at the observatory like Connor.
That is true, John. Unfortunately, I have to say we had some connectivity trouble there. So about halfway through that presentation, we got kicked off of our live stream. And I could not get both reconnected. I could not get Facebook and YouTube both reconnected. So I was able to pick YouTube and send out just to YouTube. So we're still live right now on YouTube, but I might want to rerun that presentation from Connor. I don't know if we want to do that now or do that after my presentation. It's up to you guys. But we're back online on YouTube at least right now.
Why don't you rerun it, Mark?
Okay, I'll do that.
Good evening. I am Connor, and tonight we will be speaking with NASA engineer Doug Klein. Hello, Doug.
Hi, Connor. Thanks for having me.
Doug, can you tell us a little bit about your job at NASA?
Sure. I'm currently the lead robotic arm systems engineer for the Perseverance rover, which is scheduled to land on Mars in about 3 or 4 months in February. Prior to that, I was one of the rover planners for the Curiosity rover, which landed back in 2012. And as a rover planner, I was part of the team that actually drove the rover around Mars.
What qualifications do you need to be able to drive a rover on Mars?
Most of us have either engineering or science degrees. Undergraduate degrees, generally good enough, although many have more. And then a lot of it comes from just on-the-job training. So it takes us about a year or two, depending on your background, to get all the skills to be able to drive a rover on Mars. And we do that while working.
Have you gotten to drive any rovers yet? And if so, what was your favorite part?
Yeah, so I drove Curiosity for about two years or so, and it was a ton of fun. One of my favorite jobs I've had. I think for me, the coolest thing is working with the science team and kind of getting this instant feedback where they get really excited and say, hey, we really want to go over there and look at that, outcrop of rocks or something. And then being able to help them do that and then come back to work the next day and they're, the scientists just being so excited about all these images we collected and how cool things look. So that can be a lot of fun. And it kind of feels like you're just like on this amazing road trip with this large team exploring another planet.
Is it different driving on Earth? And if so, could you explain why?
Yeah, so Earth and Mars driving are definitely different. The biggest challenge we have driving these rovers on Mars is that it can take anywhere from around 7 minutes all the way up to around a half hour to send a signal one way to Mars. And so when you're driving on Earth, you kind of just turn your steering wheel and the car adjusts accordingly. On Mars, we can't do that. And so the way we do it is we compile an entire day's worth of activities and send that to the rover all at once. And then the rover does the entire day's worth of things. And at the end of the day, it tells us what it did and sends that back to Earth. And then we wait until we get that information back and figure out what happened. So we're kind of forced to sort of do this kind of day-by-day process rather than the kind of instant type of driving you would do on Earth.
Can you use known landmarks to determine where you are, or where you need to go, or do you use other methods?
Yeah, we do use a lot of known landmarks for navigating. One of our biggest techniques that we use is using images from Mars orbiters that are flying overhead on Mars that have built up full maps for us to be able to use. And so we can locate the rover within those images, and generally those images are how we develop our strategic plan for how the rover is going to drive for several months. And so we'll do kind of 6-month out planning on where the rover is going to go. And then we can regularly update our location within those orbital maps to make sure that we're still on course for where we're trying to get.
Is driving Perseverance any different from driving Curiosity? And if so, why?
It is different. One of the biggest changes for Perseverance is that the sampling system is totally new. And so we're still in the process of kind of learning how to operate that new sampling system, but it collects cores and then deposits them on the surface of Mars for a future mission to be able to pick up and bring back to Earth, which is extremely exciting. And so that's one of the biggest differences. There's other kind of changes to the software to introduce more autonomy to make the job of the rover planners and the people operating a little bit easier.
Do you think its R-Drive feature will make your job easier or harder? And would it help you overcome the new terrain Perseverance will encounter?
I really think it will. Auto drive or auto navigation, autonomous navigation, is a way for the rover to take pictures and then decide what the safest path is to traverse. And it's something that we're looking forward to using a lot, and that we've made a lot of improvements for on Perseverance to make it more efficient and more effective for us to be able to use in a wider variety of terrain. So I think it's going to be a really cool capability, and we're really looking forward to it.
Thank you, Doug, and thank you for watching this video. If you would like to learn more, please go to NASA's or JPL's website. And for more videos, please visit the McCarthy Observatory website or our YouTube channel.
Thanks, Connor. That was great.
Good night.
Thank you, Connor and Doug. Mark Polanski is going to present next the status of the Starship rocket by SpaceX.
Evening. I'm Mark Polanski, and tonight I'm going to provide a little background and the latest updates on the SpaceX Starship Super Heavy Launcher and spacecraft. SpaceX is best known for building and flying the Falcon 9, currently the only partially reusable orbital class rocket in the world. The key word there is partially reusable. One of the main goals of SpaceX is to dramatically reduce the cost of getting to orbit by reusing as much hardware as possible. SpaceX has been very successful on landing and recovering the Falcon 9 first stage boosters and more recently the payload fairings. So what is a first stage booster? The vast majority of rockets are multi-stage vehicles, meaning the rocket's built in sections or stages, where each stage is basically its own self-contained rocket, complete with separate propellant tanks and engines. Typically, the first stage is the largest because it has the most difficult job. It must lift the entire vehicle off the pad and carry it through and out of the thickest parts of Earth's atmosphere. It takes an extreme amount of energy, and therefore propellant, to lift and accelerate the entire mass of the rocket and payload. At liftoff, roughly 80% of the total liftoff mass is the first stage propellant alone. Once the first stage propellant tanks are empty, it can no longer provide any thrust. The entire section becomes dead weight. Rather than try to carry the extra mass of all those now useless engines and tanks, the rocket disconnects and drops the entire first stage. The second stage engine can then light up and use its own propellant to boost itself and the payload the rest of the way into orbit. For every other rocket currently flying, the first stage destructively falls back to Earth after separation. SpaceX designed the Falcon 9 with enough extra performance to shut down and separate stage 1 before the tanks are emptied. It's then able to flip itself over, perform multiple engine burns, and slow itself down enough to re-enter the atmosphere without burning up and ultimately land safely. This makes the first stage recoverable and reusable for future flights. This is one of my favorite photos of Falcon 9 from the Sentinel 6 launch in November of last year. The same camera, in the same position, captured both the launch of the whole rocket on the right and the landing of just the first stage booster on the left. Notice how the upper part is now missing on the left side. The booster can be cleaned up, refueled, stacked with a new stage 2 and payload, and be ready to fly again in about a month and a half. The second stage of Falcon 9 isn't so lucky. Once the payload is deployed into the intended orbit and pushed away, the second stage reverses direction, lights its engine for a re-entry burn, and it slows down just enough to fall back into the atmosphere, where it almost completely burns up. That's the partial part of partially reusable. The first stage can be reused, but the second stage can't. SpaceX did spend some time looking into recovering the second stage, but decided the trade-offs and necessary design changes were not worth it, especially once they started seriously working on Starship. So what is Starship? Starship is the second stage of a next-generation, fully reusable launch vehicle under development by SpaceX. When fully stacked, it'll be a little bit taller than the Saturn V rocket and just about as wide. The Super Heavy booster is the first stage. Its function will be very similar to the Falcon 9 first stage, it's just a whole lot bigger. The goal for Super Heavy is to boost the Starship upper stage off the launch pad and through the atmosphere. Starship will then separate and use its own engines to get the rest of the way into orbit, while the Super Heavy booster lands back on Earth for reuse. Both stages are powered by the new Raptor engine developed by SpaceX. There should be 6 engines in Starship and at least 24 engines in the Super Heavy booster. Raptor uses cryogenic liquid oxygen and liquid methane as propellants. And this was a very important design decision. There's many benefits to methalox. The only combustion byproducts produced are carbon dioxide and water, so it burns much cleaner than the kerosene used in the Falcon 9, which can lead to much longer engine life. Methane and oxygen can also theoretically be produced on Mars, which is important for Starship to be able to return to Earth someday. It needs to be able to make propellant from Mars. SpaceX also have plans to generate methane from carbon dioxide and water here on Earth to make Starship and Super Heavy completely carbon neutral vehicles. At first, SpaceX designed Starship with relatively exotic materials like carbon fiber and advanced composites, but realized the cost and complexity of these materials at this scale don't make sense. It's about $130,000 per ton for carbon fiber, and it's only about $2,500 per ton for steel. That's less than 2% of the cost of carbon fiber. Stainless steel also has better strength to weight ratios at cryogenic temperatures, and it has a much higher melting point, meaning less of a heat shield is necessary for reentry. There's currently 4 different configurations of Starship under design: cargo to carry and deploy satellites, crew to act as a transport or a temporary space station for humans, lunar to carry people and equipment to the moon's surface as a possible part of NASA's Artemis program, and the tanker, an on-orbit refueling depot to allow other starships to refill the propellant tanks for journeys to the moon, Mars, or beyond. Starship's being designed to conservatively carry up to 100 tons of material to orbit, including people, satellites, equipment, or additional propellant, with up to a 30-foot payload diameter and up to a 59-foot payload length. SpaceX believes there's a way to upgrade Starship in the future to carry up to 150 tons of material. For comparison, the Falcon 9 can only haul about 25 tons, with a 17-foot diameter and a 43-foot payload. The cargo Starship variant will have a single hatchback-style payload fairing, opening like a car trunk to deploy satellites or equipment. The tanker variety allows Starships to dock end-to-end to initiate refueling operations, and that's a critical requirement for sending large payloads to other parts of the solar system. The key capability to making Starship a reusable second stage is the method of recovery and landing. Being a second stage, it's no small task to return to Earth from orbital velocity. It has a lot of energy it needs to get rid of. Starship's initial reentry into the atmosphere will be similar to other spacecraft. It'll have a heat shield to protect it from the plasma and heat generated by slamming into the atmosphere. SpaceX is also considering a transpirational cooling system, meaning it'll push a small amount of cryogenic propellant through the heat shield to evaporate some heat away, the same way that humans use sweat to cool ourselves. Once through the initial reentry, capsules like Apollo or Dragon would use parachutes to slow themselves down enough to splash down into the ocean. The space shuttle would glide like an airplane, sometimes flying wide circles through the sky to shut off velocity before touching down on the runway and rolling to a stop. Starship, on the other hand, will belly flop horizontally into the atmosphere and free fall like a skydiver, using relatively small flaps to stabilize itself and control its descent. before lighting its engines and pitching upwards 90 degrees for a propulsive vertical landing. It sounds complicated because it is. It's even more impressive to see it actually happen. Starship and Super Heavy are both currently under very active development in South Texas in the small village of Boca Chica. There's a development build site at the village itself and launch pads about 3 miles down the road at the coastline. SpaceX has a very capable design and manufacturing team, churning out prototypes almost faster than they can be tested. The teams are taking a rapid iterative approach to the design, meaning as problems are discovered with manufacturing, integration, or testing, they're corrected in real time and the improvements are immediately fed into the next prototype. This lets them fail fast and push ahead significantly faster than traditional aerospace development. To really get an idea of what fast means, the first Starship prototype began construction in December of 2018. At first, people thought it was just a water tower or some piece of infrastructure for launching Falcon 9. As the weeks went by, it became apparent this was no water tower, especially after a Raptor engine showed up and got installed. It ended up being a portly looking tank with legs known as the Starship Hopper or Starhopper. It fired up its one Raptor engine for the first time on April 3rd, 2019, just 4 months after construction began. 4 months after that first test, it fired up its engine again, this time hopping to an altitude of 20 meters and landing back in place. By late August, it flew to an altitude of 150 meters, landing safely on a pad about 100 meters away from the launch site. This thing just looks ridiculous, like it has no business flying, but there it is. It only took 9 months from the initial construction to a free-flying experimental vehicle, and the pace only increased from there. At first, SpaceX wanted to double their odds of success with prototyping, so they set up 2 competing build sites, one in Boca Chica and one in Cocoa, Florida. The challenge was to develop the most efficient build strategy for constructing Starship. In Boca Chica, construction began on Starship Mark I, the first full-scale prototype. Simultaneously, construction of Mark II began in Cocoa, Florida. By late 2019, the resources of both sites were consolidated into Boca, and Mark II ended up being scrapped. It's important to note here that there are not separate tanks inside the vehicle. The vehicles themselves are the tanks. As they weld each section together, the welds and steel need to be strong enough to hold the pressure of the propellants within. In September of 2019, Mark I was structurally completed, and it was used as a mock-up when Elon Musk presented the latest updates and progress on Starship. In November, it was brought to the launch site to test pressurization, where it failed and the top blew off a few minutes into the test. Mark III started construction at Boca Chica in October of 2019. Not long after, it was renamed to SN1, or Starship number 1. 4 months later in February, it was ready for pressure testing, where it shared the same fate as Mark I and failed under pressure. Learning from 2 pressure failures, SN2 was built only as a small tank section instead of a full-size vehicle. After analyzing the failures from Mark I and SN1, they decided to test their manufacturing refinements before building another full Starship prototype. SN2 successfully held pressure as expected, allowing the full-sized SN3 prototype to proceed. SN3 was destroyed, but not because of a pressure failure. It was a procedural testing error. Basically, the vehicle needs to be pressurized to be structurally sound. Think of an air mattress. When it's not fully inflated, it can't support any weight. Starship has 2 pressure sections, one for liquid oxygen at the bottom and one for liquid methane at the top, like 2 air mattresses stacked on top of each other. Typically, liquid nitrogen is used for cryogenic pressure testing because it's an inert material. There's no big fiery explosion if the tanks fail. With SN3's test, somehow the top section got filled up with liquid nitrogen while the bottom section remained unpressurized, causing the weight to collapse to the bottom. SN4 fared slightly better. It successfully passed cryogenic pressure testing and was eventually able to test fire its Raptor engine 5 times. It was intended to do another 150-meter hop similar to Starhopper. Unfortunately, after the last Raptor test, one of the propellant quick disconnects on the launch mount failed, causing methane to leak all over the launch pad. After a few minutes, the methane ignited and the whole vehicle exploded in late May. The pad was quickly cleared and repaired, though. By July 30th, SN5 took to the pad with a successful engine test firing, and not long after completed its flight to 150 meters, including a safe landing. SN6 repeated the success a month later with a much smoother flow from pad installation to flight. Lessons were very obviously being learned and applied as each failure led to the next success. SN7 was another test tank similar to SN2. With the success of SN5 and 6, the SpaceX team wanted higher safety margins in propellant tank pressure. SN7 tested new welding methods to increase the maximum pressure the tanks could handle. 7.1 was also a test tank, this time testing a new stainless steel alloy along with the refined welding methods to further increase the maximum pressure. This tank was able to safely hold pressure up to 8 bar, which is double the pressure required for flight. SN8 became the first completed Starship prototype, including the nose cone, aero flaps, and 3 Raptor engines. All the previous vehicles only used one engine, with a mass simulator in place of the nose cone and flaps. It was the first to test the complete flight profile, launching to almost 8 miles in altitude, belly flopping, skydiving, and pitching back vertical for a landing. Elon Musk gave this flight only a 30% chance of success, saying he'd be happy if it got off the pad and went past 150 meters in altitude. So let's take a look at how it went.
Stage for office, go for flight.
It also has to do the fuel line, there's not a lot of excess miles to reach the weight. SN8 managed to achieve the target altitude. It was the longest operational Raptor burn to date, demonstrated the belly flop reorientation and a stable and accurate free fall, right up into the pitch and landing maneuver. Even though it didn't successfully land, it checked off the most critical milestones for testing this radically different flight profile, and it's considered a huge success. After the flight, Elon explained that the propellant tanks used for the landing burn didn't have enough pressure to keep the Raptor engines well fed, so they couldn't slow the vehicle down enough to land safely. The enormous amount of data gathered from the SN8 flight will feed directly into SN9's test flight. And that's the nice thing about rapid development. SN9 was largely completed before SN8 took to the sky, and it's now on the launch pad waiting for its chance to fly. It briefly fired up its 3 Raptor engines earlier this week for the first time, and it'll fire them up again for a longer test as early as Monday, and it could fly at any point next week. It'll follow the same flight profile as SN8, though this time they hope to have the header tank pressure issue resolved so we could see a successful landing. And if it doesn't complete all the objectives, SN10 is now mostly completed and can fly in a few weeks using lessons learned from SN9. While failure is never a desired outcome, it's not necessarily a bad thing in a rapid development system. It's actually expected sometimes when the goals are set high and planned for by having the next prototype ready to go to continue the learning process. To that end, SNs 11 through 17 are well underway. They're all being assembled and there's parts already on site for them. BN1, or Super Heavy Booster number 1, is also starting to take shape. Parts for it started showing up in September of last year, and assembly is steadily proceeding. Elon has said that Starship is by far the most difficult piece of this whole puzzle, due to the radically different entry and flight profiles. The booster can lean heavily on Falcon 9 flight experience for descent and landing. The construction methods for the booster are also identical to that of Starship, using the same stainless steel and welding techniques. Many of the lessons learned building and testing the Starship prototypes are directly applicable to the booster as well. We're hoping to see the first booster test flights within the next few months, with the possibility of a fully stacked Super Heavy booster and Starship making orbital attempts by the end of this year. To summarize, Starship and Super Heavy are a next-generation, fully reusable launch system. SpaceX has been able to go from construction of the first small-scale tests via Starhopper to a complete flight profile test of SN8 in about 2 years. SN9 could be flying next week, hopefully with a successful landing, with SN10 not far behind. New Starship prototypes are built every 4 to 6 weeks, with each using lessons learned from the previous ones. We could see an orbital flight test as soon as later this year. If this system works as designed, it could pave the way for space travel to become as commonplace as air travel, which is something really exciting to think about. Thank you. And join us on February 13th for another online Second Saturday Stars. And as Roger mentioned earlier, please subscribe to our YouTube channel.
Thank you, Mark. For our audience, all of the presenters, including Doug Klein, are here and ready to take your questions. You can message them through Facebook, and they'll be relayed to the speakers.
No questions at the moment, but we'll give it another minute or so.
Okay. If nothing else, then we'll thank everyone for attending and remind you to visit the JJMO website, www.mccarthyobservatory.org, to see the schedule for next events, to find our YouTube presence and our Facebook presence.